Hello and welcome to the second videos for chapter 4, and hopefully we'll be touching a little bit on chapter 5. So we need to go over three terminology, actually three acronyms, sorry. We need to have Ascii and Unicode and ISO. If you take a look at your keyboard, you will wonder what type of characters that we have. What are the characters? As I'm looking at it, it's really they include the digits 0 through 9, then the alphabet A through Z, capital and lowercase, and all sorts of punctuation and symbols. But also there are characters that we don't see. They're non-portable. How do we actually represent every character as a unique value? Historically, if we're going to forget about the rest of the world, we're going to worry about the United States, since most of the invention in the 20th century was made in this country. So we use the ASCII, which is the coding system that stands for American Standard Code for Information Interchange. And this is a coding system that used 1 byte. Okay, and as we all know, there are 8 bits in each byte, and we know that each bit will take one of two values, either on or off. So the base for the binary system is 2, and I have 8 bits, a combination of 8. So the variation that I could obtain with 2 outcome and 8 bits is 2 raised to the power of 8, which is going to give me 256 combination of characters. Those characters, as you probably, some of you know, the different type of character that we represent in reality. So if I go to Google here and ask for ASCII table, I wanted to go to the extended ASCII table, and you will notice that, let me get a better looking one than this one here. All right, in this one here, as you notice, if I make it a little bit bigger, all right, it will make sure that we do have 0 all the way to 255, because that's the total number is 256. If I told you how many digits in the decimal system we have, you'll tell me 10. And if I ask you what are they, you say it's 0 through 9. The same thing here is 0, 20, 255. And if you notice, the first 31 characters in the ASCII table are non-printable characters. For example, the escape key, it's 27. The carriage return or the enter key, it's actually carriage return is 13. And the line feed, which is the new line, it's going to be 10. And also we have a sound, which is the bell, which is the ASCII value of 7. If we start looking at something tangible for us, the space is a tangible. We can see it when we hit the space bar. It's the value of the ASCII for that character is 32. Then you would notice that 48, we start with the 0. I mean, the bracket is 41, the open bracket is 40, and ampersand is 38, the 37 for the percent sign. And we could go to the 0, 48 all the way to 9, 57. And we start with the letters A 65 all the way to 90 with capital. And we have some special characters here in the middle for good reason, because we want to keep the bit of 32 either off or on. If we held the shift key, it's going to turn it off. Actually, it's going to turn it on, sorry, which is going to get the capital characters. That's the difference between a capital character and a smaller character, is the shift, which is really turning on or off. Turning off the, in order for us to get the lowercase, turning on the shift key, which is going to get us the uppercase. And here we go, we're going to go ahead and A all the way to Z. Then we have special character, European characters, and all sorts of Greek characters included as well. So you get the idea here that the special characters that we use is really built directly into the ASCII. But what happened to the world in the last 20 years? What happened to the world in the last 20 years that we don't represent anymore ourselves? There are other languages that are lively and vital to the global aspect of our reality or globalization. So if I wanted to write, I love my daughter very much, and I would have to go to Google, and I would have to use Google Translator. So then I start by saying translate google.com, and I would type here, I love my daughter, and I love my daughter very much, which I do. Okay, and in this case, if I put that into Arabic, it says whatever it says in Arabic. If I wanted to change that to Japanese, that's the last two language that I use. This is how it says, I love my daughter in Japanese. Notice both Arabic and Japanese are non-Latin based. They're not part of the 56 character that existed in the ASCII. So we have a question to ask, where are these character comes from? These characters, of course, we have Japanese, we have Chinese, we have many other languages that have nothing to do with English or Latin-based characters or Greek characters. You could go into, for example, let me show you here, Urdu. I think this is a different from Arabic, but it's very much similar to it. So we could see that those are language are not basically, they exist in our typical 256 character. So what we ended up doing in the computer world is to really expand this capability to include more than 255, especially if you take a look at the Chinese language where we have thousands of characters. So the 255 is going to be too little, you know. So we moved to the Unicode system, which is universal code, with 2 bytes. And you would wonder what one additional byte will do. Let me show you. 16 bits now, 2 multiplied by 8, and that's 2 raised to the power of 16, which is going to result into 65,536 combination, which resulted from 0 all the way to 65,535 number of characters. So we have 65,536 characters that are accommodated for most of the recorded language in the world. But what about if we have added additional one and we run out of room with the Unicode? So for that, we are ready for it. That moment when we move into the using of international standard code organization, organization, and I need to capitalize the S here. Okay, and I need to check my spelling with international. I'm a little bit too hyper, so I get to misspell things. And this uses 4 bytes. Wow. And that's going to give me 32 bits. And look what will happen when I raise 2 to the 32. It's going to give me over 4 billion. And I'm going to go ahead and use Excel for that purpose. My friend Excel is going to come in handy when it comes to calculation, calculating all sorts of numbers. And here we go. I'll show you in a second what is 2 is basically raised to the power of 32. And that is 4,294,000 different of characters. So I'm going to go ahead and make it actually take also the 2 digits that are right at the decimal points because it's a whole number. And notice here, if I copy this and paste it in here, it shows you the number of the character that we have associated with 32 bits. And international standard number could be a reality sometimes in the future, but at this moment, Unicode is the most commonly used. ASCII is, or one of the other is a subset of the others. I think ASCII is the first 256 character from the Unicode, and after that, you will find the rest of the code in the world for many, many languages that exist in this planet, which make us a human race. That's really what Unicode made it possible for us to read a letter in a different language that I could not read it unless I used a translator 20 years ago. Thank you for watching.